In this lesson, we deal with more complex equations. In lesson 1.1, you saw that most of the equations just had like one step to do and then you were done, which is not realistic. So what we have in this lesson is a little more complex equations, harder to do in your head, so that's why I tried to build up that foundation. And when you want to solve a multi-step equation, you need to simplify each side if you can. You'll see what that means in a moment. And then you use inverse operations to isolate the variable. Now, the way that you decide which operation to undo is you go to your old friend from 7th grade, 6th grade, maybe 5th grade? I'm not sure. 4th grade maybe? I don't know. But it goes back a long time. GEMDAS or PEMDAS, depending on what your teacher did. But we use GEMDAS in my class. And GEMDAS stands for grouping symbols, right? So it's not just parentheses, that's why we use the G, because grouping symbols are brackets, they're fraction bars. In an upcoming lesson, we're going to look at absolute value symbols. Those are all grouping symbols. Then exponents, multiplication, division, addition, subtraction, and what we do is when you're trying to decide which inverse to do first, you do them in the reverse order. So you go backwards. So if you look at example 1, we have an equation with more than one step, and what you do is you say to yourself, self, what operations do I have? Well, a number next to a letter is multiplication, and then this is being subtracted. So what you do is you look at your good old friend GEMDAS, and you say, if I'm going to go backwards, which operation am I going to remove first? So first you're going to get subtraction, which I actually have. So I'm going to attack that subtraction first right away. So I'm going to inverse the subtraction by adding 13 to both sides. So when I do that, the 13s cancel out. I get 2.5x equals 15. Now I just keep cruising right along down GEMDAS, and I did subtraction. Now I'm on addition. I don't have any addition. I don't have any division, but I do have multiplication, right? So this right here is multiplication. So the way that you inverse that is you divide both sides by 2.5, and you might want to get your calculator out. 15 divided by 2.5 is 6. So x equals 6. Now it does say to check our solution because we want to make sure that we did it right. With more steps comes more opportunities to make a mistake. So I'm going to write my equation, but instead of x, I'm going to put 6. So I have 2.5 times 6, remember don't use the x, minus 13 equals 2. Now when you're doing a regular question just like this, it just goes back to 4th or 5th or 6th grade. You just do regular order of operations. We're not inversing anything, we just go regular order of operations. So the first thing order of operations says to do is to do 2.5 times 6, which I know is 15. Oh, what? That's weird. So 15 minus 13 equals 2. And don't just write it and then go, yeah, I know it's right. Actually do it. 15 minus 13 is 2. So you get the same thing on both sides. Check mark, move on. Now, in the very beginning, I said that you have to simplify each side if necessary first. And this is an example of that. If you notice right here, on this right-hand side of the equation, in example 2, I have these things called like terms. Like terms have the same variable and exponent. So I've got a 9x minus a 6x. So the first thing that you do before you even consider inverse operations is you combine those to say 3x plus 15. And then you bring down negative 12. So you simplify the equation first. Now it looks like a super easy equation you maybe could have done last year or in 6th grade. I'm going to subtract 15. And I get negative 27 equals 3x. Divide by 3. So x equals negative 9. Now, the more steps you have, the more opportunities there are to make a mistake. That's why it's really important to check. So I'm going to rewrite the original equation. When you're checking, you always go back to the original. So negative 12 equals 9 times negative 9 minus 6 times negative 9 plus 15. And you might say to yourself, that's so much more work. Why can't I just use that green equation that Miss Lean wrote down? Because you could have made a mistake there. So I just do my calculations. So that's negative 81. That is plus 54 because a negative times a negative is a positive, plus 15. So now you just go left to right, calculator out, negative 81 plus 54 plus 15. Luckily, I get negative 12. Now, if you don't get negative 12, then you know you did something wrong. All right, now if you look at the equation in example 3, you're like, holy cow, that's more complicated than all the other ones. So good thing I have that foundation of inverses that we've been practicing. So there are actually two ways to solve an equation like this. The first thing is to just do it standard, where you do the distributive property, right? Because the rule is simplify each side first before you start doing inverses. So I'm just going to write the equation over. Alright, now I'm going to do distributive property first. So the distributive property is when you multiply a number that's right outside the parentheses by everything that's inside. And just be careful, you're not going to distribute this 2 all the way to the 3 because it's not in the parentheses. So here we go. 2 minus 2x plus 3 equals negative 8. Next step is to combine like terms. So I've got a 2 and a 3. So that gives me 5 minus 2x equals negative 8. And now I can do my inverses because everything's simplified. So I'm going to subtract 5 because the 5 is positive. And when I bring it down, I'm going to bring down negative 2x equals negative 13. Divide both sides by negative 2. And I get x equals positive 6.5. And you pause for a second and you say, I probably made a mistake because everything's supposed to be a whole number, but in real life it's not. So you might feel a little unsure about whether you did it right or not, so let's just quickly check. Alright, so regular order of operations is in the check, so the first thing I'm going to do is the parentheses. So I get 2 times negative 5.5 plus 3 equals negative 8. And so now that gives me negative 11 plus 3 equals negative 8. And see, it all worked out. We freaked out for nothing. Negative 8 equals negative 8. Alright, that's one way to do it. Another way to do it is to divide by 2 earlier. So I would say method 1 is the method if you like very traditional work. If you're a little more on the adventurous side, then I'm going to show you another way to do it that will certainly work as long as you kind of follow your inverses. Alright, so here's another way to do it. You could first move the 3, which would go against what I told you, which is simplify each side first, but just kind of play along. You could move the 3 first, and you get 2 times 1 minus x equals negative 11. Then, what you could do is you could divide by 2 to make that go away. And the reason we can divide by 2 is because it's outside of the parentheses. So then I just have 1 minus x equals negative 5.5, and you can solve it from there, right? So you'd subtract 1, and then you would divide by negative 1, and you see you'd end up with the same answer. You just do it a different way. So whichever way you like, I will let you use, but just be careful if you're going to use method 2, you have to kind of remember what everything represents. Alright, let's check out example 4, a word problem. So they want us to use the table to find the number of miles, which we're going to call x, that you need to bike on Friday so that the mean number of miles biked per day is 5. Now remember, mean is another word for average. And the way that you find the average is you add them all up and you divide. Perfect. So we know how many miles we biked on all the other days. So if we add up all of the things, including Friday, which we don't really know, we know that the total has to be 5. So here's what my model would look like. So I added up all of my values, including the x. I divided by 5, and they want us to have an average or a mean of 5. So first step is to simplify everything. So when you simplify the top, you get 14 plus x divided by 5 equals 5. And then you just have to do your inverses. So I'm going to inverse the 5 because this fraction bar is what we called a grouping symbol. So it's grouping the 14 plus x together. So if we think of GEMDAS backwards, the first thing I'm going to do is get rid of the division because I have this grouping symbol with the 14 plus x. So multiply both sides by 5. You get 14 plus x equals 25, which means that x has to be equal to 11. So you must have gone 11 miles. You look back and you say, doesn't make sense, and the way that you can do that is you add them all up and you say, in the table, if I put in 11 for Friday, do I get 5 when I get the average? Alright, one more word problem. Pause the video, read the story, and we'll solve it. Alright, so the plan is right here, over on the side. So first we have to understand the problem. So we know how much the club charges for admission. We also know how much the club borrowed and its profit. And what we have to find is how many people attended the play. So first thing is you break it down and you say, what is this asking and what information do I have? Now I'm going to make a plan. Now the plan, as we're in chapter 1, which is equations, is I'm going to make an equation. So here's my plan. Ticket price times the number of people who attended, right? Because if one person attended, it's $4. If 10 people attended, it would be $40. So ticket price times the number of people who attended minus this loan that I took out should be equal to what I have left, which is 100. So that's my plan. Now I'm going to solve it. Why don't you pause the video and solve that? So I got 125 people. Last step is just look back and make sure that makes sense. If it's $4 a person, 125 times 4 is 500. And then don't forget you had that loan, so $100 totally makes sense. And so if you have any other questions, write them down and ask me when you come to class.